All right, hi everyone. So let's take a look at loops, for loops in particular this time around. So this is part 2 in our series about loops. And we're going to talk about loops, but of course, it's always a good idea to have access to a nice reference. So here's a reference to the Java 8 Fundamentals book in the York University Library. And in chapter 5, you will find a section on the for loop statement. All right, so the for loop, what is it? Well, it looks something like this. So what we have right here is the keyword for. Then we have a parenthesis there. We have a parenthesis there, around brackets. We have this business right here, which is basically the counter that's used inside of the for loop. It's separated using a semicolon right here from the test condition that's found inside of the for loop that we check every time we go through another iteration of the for loop. And then you have this condition right here, this operation right here that occurs at the end of the for loop to basically change the value of the counter that's found right here. And then inside of the for loop, you have these, well, in between these curly braces right there and there, is you have whatever's supposed to be executed every time the for loop goes through. Now, visually, we can take a look at a for loop, and it looks something like this, where you've got an initial action. So in our case, I is equal to 0. Then from the initial action, we traverse down into a question, and the question is shown in flowchart form as a diamond right here. All right, and this is the loop continuation condition. And so in this case, we're asking, is the counter I less than 100? And there's a question mark right here. That question needs to be asked. The answer to the question can be false, which happens at the very end of our looping, or it can be true, which is what happens during the looping activity. Okay, so if we go to true right there, otherwise we're going to false like this, and this is the end right here. Okay, that's the end of our loop. If we get true, then we execute whatever's in the body of the loop. In this case, it's the print to the screen, the print line, welcome to Java. Then once that's done, then there's this action after each iteration. That's the I++, or I is equal to I plus 1. That's another way of writing it. That's, for some of you, this is the more straightforward way to write it. Okay, so that's basically a loop. Oh, forgot this part. When we get to the I++, we go back over here and we start again. If we do the after the action, or action after each iteration, we go back and we ask the question again. All right, so here's this for loop written out in a way that Java recognizes. All right, so each time we go through, we're going to take a look at the internal condition right here, and we're going to decide whether or not we enter a state in the loop, and we're going to see what happens with iterations, and then what actions are taken. All right, so the very first time that we enter the loop, I, this counter right here, has a value of 0. It's initialized to a value of 0. Then we ask, is I less than 100? Well, I is 0, so yes, it is true. So we stay within the loop. This is our first iteration, and then what we do is we print, and then what we do is we change the counter value. We do I is equal to I plus 1 or I plus plus. We now have the second iteration through our loop where I is equal to 1. Is I equal to 1 less than 100? Yes, so it's true. So this is iteration number 2. This is the second time we're going through. And so we print that statement, this one right here, and then we do that. So the actions, this action happens first, then that action happens second. All right, next go around. I is equal to 2, okay, because we have just done that. And so now I is equal to 2, that's less than 100. The true state, we have a true answer to the for question, diamond, and so we stay within the loop. We iterate, this is our third iteration, and we print, and we increment, and on and on and on, until we get to the 99th iteration. Now 99 is less than 100, so yes, we stay within the loop. We then go into our 100th iteration, so the, this is the 100th iteration, okay? We're going to print. We're going to print for the last time, and we're going to increment for the last time. We've now come back up. Okay, so we've done our last we're coming back up, and we're now going to ask that question. So we're now going to be in the diamond of that that flow chart. Okay, in here we now ask the question, that diamond. Okay, so we're in that diamond of the flow chart. We're going to ask, is 100 less than 100? And the answer to that is false. 100 is not less than 100, it's equal to 100. So the answer to the question is false. We now will not continue on. We do not engage in any of the actions. So we do not do this, and we do not increment again. We simply exit. And so the number of iterations, in this case 100, corresponds to the number of times the loop body is executed. The number of times that we check the stay condition, that is to stay within the loop, we do that 101 times, is the number of iterations, in this case 100 plus 1, because that last time is the one in which we say, nope, we're not staying in the loop, we exit. Now, this is sort of how this looks like in the order of operations and things like that. What does it look like when we implement it in, say, the J shell or in IntelliJ or Eclipse or one of these other IDEs? Well, there's two other videos that I've made that show how this is implemented. Basically, what we do is we get into what happens at the terminal, and you can see in the terminal right here that I've entered J shell, and I have a for loop right here, and it shows that you can print welcome to Java, etc. a bunch of times. Now in this case, we only looped 5 times because I wanted to make sure that you'd be able to see it on the screen, but that's what's going on right there in the Java shell. We can also do it in IntelliJ, and so you can see right here, this is an IntelliJ project, and inside of the main method and inside of a class called myLittleLoop, I have got my for loop. So if you're looking to code this up and just try it out, the J shell is actually the simpler way to do it. But if you like the IDE and you can set up the class, and then inside of the class you can do, say, a main method, then you'll be fine. You'll be able to make this up and make it run. And then down here, you'll be able to see it actually working down in the bottom of the IntelliJ window. Okay, so let's go back to the presentation right here. All right, so the for loop. The for loop has this initializing condition, I is equal to 0. It has this counter called I. We have a test condition, I less than 100. And we have an incrementing condition as well, this extra step that happens at the end in order to make your variable change. All right, so there's this initial action right here that's executed only once. And it turns out you can actually remove this and put it before the for loop. Okay, you have the action after each iteration, and this is executed repetitively to make progress so that it can be moved to the end, and we can actually move it to the end of the for loop as well. Okay, so we can actually modify how this looks. This is the standard way. This is the standard way of how we would write these for loops, but you can write it differently. So for instance, we can put that initial condition at the very beginning, I is equal to 1, make it an integer, or I is equal to 0, make it an integer. And then what we can do is we can leave that part right here that comes between the, I'm just going to do that again here, between the parenthesis and the semicolon, we can actually leave it blank, just as for the same sort of reason. After that semicolon right there, and just before the parenthesis right there, the round bracket, you can leave that blank. Okay, that's where we do the increment. You can leave that blank, you can put it at the end. Okay, so we still have the same body as before, the print statement. And then right after the print statement, we can say I is equal to I plus 1, like that. Or we can do I plus plus. Either way, it'll be the same thing. And then we close the curly brace on the for loop. And that's basically the same thing. All right, next up, let's compare the behavior of this particular program. Okay, so the very first one. Well, this is a block within the program, okay? So we got 4, and then we have our counter, and it's an integer, and it initializes to 0, and we're looking for all the counts less than 100, and we're going to increment our count, and then we're going to welcome to Java, okay, as a print statement. Now compared to this, so we've got the same for loop right there. We still have an integer as a counter. We start the integer at 1 instead of 0, and we're going to go up to 201 instead of 100, and we're going to count, instead of going this right here, this would be count is equal to count plus 1, and this right here is the same as saying count is equal to count plus 2. Okay, it's the same thing. What's the difference between these two? Well, are the outputs going to be any different? Well, it turns out no. They're both going to print out the statement the same number of times. It's just that the internal incrementing counter, count in both cases, is just going to have different internal values. So in one case it goes 0, 1, 2, 3, etc. all the way to 100. In the other case it basically counts in odd numbers, 1, 3, 5, 7, etc. all the way to 201. It has the same number of iterations. So it'll loop the same number of times and print the same number of welcome to Java on the screen. Okay, so it'll run exactly 100 times and you won't see any real difference. So you can choose your counter values to be a whole lot of different things. What's important generally is the number of times that loop goes through. Okay, so let's compare the behavior of this particular block of code right here. All right, so we've got int count is equal to 0. We have left it blank right in there just before the semicolon. And look, we're going to make this blank at the end because we're going to increment after our print statement explicitly. Okay. Now compare it to this one right here. So count is 0 here, count is 1 there. Count we've set to count less than or equal to 100 there, but we've made count less than 100 there. So we've changed our initial condition, and we've made the test condition that's in the middle of the for loop that gets tested every time different. We've got the count plus plus, or count is equal to count plus 1 at the very end, not built into this part of the for loop, but at the very last part of just before the curly brace there. And we've done the same thing right here. Is there going to be different? Well, so both loop bodies run exactly 100 times, and they depend on the value of count. Now, count is being displayed in both cases, but the values of count are going to be different. All right, next up, compare the behavior of the following 3 programs. So we've got, or blocks of code. We got for and int I is equal to 1, I less than or equal to 5, I plus plus, and then print. And all we're going to do is print out the value of I. The end result, this is print and not print line. Okay, so because of that, it prints this first, and that, and then that, and then that, and then that, one after the other. And because there's no new line, they all get placed one after the other. All right, now compare it to this, where we've removed the I is equal to 1 out of here. We've placed it up there, and we've taken the I plus plus, or the I is equal to I plus 1, and we've moved it down there. Compare it to the first one, and the output will be basically the same. Okay, it'll be 1, 2, 3, 4, 5. Writing your for loop this way or writing it that way gives you effectively the same thing. Now let's compare it to this. So in this case, we've got the starting condition right here that's been removed and placed up there. The end condition has been placed in the body of the for loop between those curly braces right there and there, but we placed it before system out print. Okay, it's not going to do the same job. Instead, it's still going to print out, let's see, we had 1, 2, 3, 4, 5 digits. 1, 2, 3, 4, 5 digits. Sorry, but they're not the same digits. And that's because we incremented I, after we did the test over here, we incremented I before we printed to the screen. So 1 never gets printed, only 2 does. And instead of just ending at 5, we end at 6 because we increment before the printing occurs. That's basically the difference. So there are different ways of writing our for loops. There are very standard ways of doing it, and then depending on what the goal of your program is going to be, you could print it out different ways. So sometimes you want to have a slightly different printed out value than the internally tested values right here, and there can be reasons for that. So this isn't just a mistake. This could actually be an intentional thing. So, but the end story right here is that there are different ways of writing your for loops.